Take your phone out of your pocket. Whether it's an iPhone, a Samsung Galaxy, a Google Pixel, or almost any Android device, there's a good chance they all have one thing in common. At the heart of each one is technology from the same company, a company that most people have never heard of. Here's the strange part. ARM doesn't manufacture computer chips. It doesn't own billion-dollar factories. It doesn't sell smartphones. And it doesn't compete directly with Apple, Qualcomm, Samsung, or MediaTek. Yet somehow, nearly every smartphone on Earth depends on ARM's technology. How is that possible? How can a company that doesn't build chips become one of the most important businesses in modern technology? The answer is surprisingly simple. ARM doesn't sell products. It sells ideas. And that decision transformed a small British startup into the invisible foundation of the mobile revolution. The story begins in Cambridge, England, during the early 1980s. Back then, the computer industry looked completely different. Personal computers were just beginning to enter homes. Companies believed the future belonged to larger, more powerful machines. Speed was everything. Processors kept becoming faster, but there was one problem. They also consumed more electricity. For desktop computers plugged into the wall, that wasn't a huge concern. But what if computers eventually became portable? What if one day, people carried them everywhere? That future required something entirely different. Not just more power, better efficiency. A small British company called Acorn Computers faced exactly this challenge. Its engineers needed a processor that was fast enough for modern software but efficient enough to avoid wasting energy. Existing designs didn't meet their needs, so they made an unusual decision. Instead of buying a processor, they would design one themselves. That project eventually became the Acorn RISC machine, later known simply as ARM. At first, almost nobody outside the computer industry noticed. ARM wasn't trying to become another Intel. It wasn't chasing desktop computers. Instead, its engineers focused on one simple philosophy: keep everything as efficient as possible. Most processors at the time followed a design philosophy called Complex Instruction Set Computing, or CISC. They included hundreds of complicated instructions designed to perform many different tasks. ARM chose the opposite direction. It embraced reduced instruction set computing, better known as RISC. Instead of asking processors to perform fewer but more complicated instructions, ARM designed chips capable of executing simpler instructions extremely efficiently. That approach delivered something revolutionary: lower power consumption, less heat, longer battery life. At first, many people dismissed the idea. Desktop computers still dominated technology. Performance mattered more than efficiency. But ARM wasn't designing for the present. It was quietly designing for a future that hadn't arrived yet. Then the world changed. Mobile phones became smarter. Personal digital assistants appeared. Portable electronics exploded in popularity. Suddenly, battery life mattered just as much as processing power. Every extra minute of battery became a competitive advantage. And that's exactly where ARM's designs excelled. Instead of consuming enormous amounts of energy, ARM processors delivered excellent performance while using remarkably little power. Manufacturers quickly noticed. One company after another began licensing ARM's architecture. The company wasn't selling finished chips. It was licensing the blueprints. This is where ARM's business model became incredibly powerful. Imagine designing the blueprint for a house. Instead of building thousands of houses yourself, you license the design to construction companies around the world. Every builder pays to use your design. They construct the houses. They take on manufacturing costs. You simply continue improving the blueprint. That's exactly what ARM did. It designed processor architectures. Companies like Qualcomm, Apple, Samsung, MediaTek, and many others customized those designs into chips for their own products. ARM didn't need expensive semiconductor factories. It didn't need to compete with its customers. In fact, the more successful its customers became, the more successful ARM became too. That licensing model allowed the company to scale across the entire technology industry without carrying the enormous manufacturing costs faced by traditional chipmakers. And as smartphones began replacing ordinary mobile phones, ARM found itself sitting at the center of the biggest consumer electronics revolution in history. Almost overnight, its technology spread into hundreds of millions of devices, then billions, without most consumers ever realizing the company even existed. Because while Apple, Samsung, and other brands competed for customers, they were often relying on the very same foundation hidden deep inside their devices. And that invisible position would become one of the strongest competitive advantages in the entire semiconductor industry. One of the biggest reasons ARM became so dominant was that it never tried to win the hardware race. Instead, it helped everyone else win theirs. Even smaller chip designers around the world, they all wanted processors that were faster, more efficient, and optimized for their own products. ARM gave them exactly that. Instead of forcing every customer to buy the same chip, ARM licensed its technology. Each company could customize the architecture to fit its own needs. Apple optimized it for the iPhone. Qualcomm designed Snapdragon processors for Android devices. Samsung built Exynos chips. MediaTek created affordable processors for millions of smartphones. Different chips, different brands, the same ARM foundation. This flexibility became ARM's greatest competitive advantage. The company wasn't competing with its customers. It was empowering them. Of course, ARM doesn't exist without competition. Intel continues dominating many traditional PC and server markets. AMD has become a major force in high-performance computing. RISC-V, an open-source processor architecture, is gaining attention as a possible alternative. Some companies hope it could reduce their dependence on ARM licensing. Technology never stands still. Neither does competition. But ARM has something extremely difficult to replace. An ecosystem built over more than 30 years. Millions of software developers. Thousands of hardware companies. Countless engineering tools. Entire operating systems optimized around its architecture. That's not something competitors can recreate overnight. Another remarkable part of ARM's business is its economics. Unlike semiconductor manufacturers spending tens of billions building factories, ARM's biggest investment is research and development. It designs intellectual property. Its customers handle manufacturing. Companies like TSMC and Samsung fabricate the chips. ARM simply continues improving the blueprints. That means it benefits as the entire semiconductor industry grows. When Apple sells more iPhones, ARM benefits. When Qualcomm ships more Snapdragon processors, ARM benefits. When MediaTek expands into emerging markets, ARM benefits. Instead of betting on one hardware winner, it quietly supports almost all of them. That's one of the smartest platform strategies in modern business. Perhaps the biggest lesson from ARM isn't about processors. It's about focus. Many companies believe growth means doing everything themselves, building products, owning factories, controlling every step. ARM chose the opposite path. It specialized. It became exceptionally good at one thing, designing efficient processor architectures. Then it allowed thousands of other companies to build on top of that foundation. Instead of competing with everyone, it became essential to everyone. So why does ARM power nearly every smartphone on Earth? Because decades ago, while everyone else chased raw performance, ARM focused on efficiency. While others built chips, ARM built the blueprint. And while manufacturers competed for market share, ARM quietly became the technology connecting them all. Today, billions of people use ARM-powered devices every single day without ever seeing its logo. That's the mark of truly transformative infrastructure. Sometimes the most powerful companies aren't the ones making the headlines. They're the ones making everything else possible.